Hello everyone, we're from 12 Cecilia of St. John Catholic School. We would like to discuss the theory of atom. There are four theories of atom, and the one that we will discuss first is the theory from John Dalton. According to John Dalton, all matter is made up of indivisible and indestructible basic particles called atoms. All atoms of a given element are identical, both in mass and in properties. Atoms of different elements have different masses and properties. Compounds are formed when atoms of different elements combine.
Dalton also stated two kinds of law. First one is law of definite proportions. Law of definite proportions means all samples of compound contain same weight proportions of constituent elements. Second one is law of conservation of mass. It is stated that initial mass is equal to the final mass, and only reorganizing of unchangeable atoms occurs in a chemical reaction. So here is the example of Dalton's atomic theory questions. The weakness of Dalton's atomic theory is that it doesn't explain A. Atoms have nuclei and electrons. B. Atoms of similar elements have different properties. C. Gas atoms cannot join. D. Atom cannot be divided. E. Atoms can combine to form molecules. So the answer is A. Atoms have nuclei and electrons because Dalton's atomic model does not explain the nucleus and electrons.
J.J. Thomson theory. He discovered the electron by using the cathode ray tube, and he knew that electrons could be emitted from matter. He proposed that atoms consist of small negative electrons embedded in a massive positive sphere. The electrons were like currents in a plum pudding. That's why it is called the plum pudding model of atom. Moreover, he made a calculation between the charges of electron and mass of electron. So here is the question. One statement about Thomson atomic model is A. Electrons can absorb energy. B. Electrons gather to form atomic nuclei. C. Atom is the smallest part. D. Atoms have uniformly distributed positive and minus charges. E. The electrons are around the atom core. And the answer is D. Atoms have uniformly distributed positive and minus charges.
In Rutherford's model of atom, an atom has a positively charged nucleus. The majority of the atomic mass is located at the nucleus. The nucleus is surrounded by negatively charged electrons, which move the way planets orbit the sun. An atom is neutral, so the charge of nucleus is equal to the charge of electrons. The nucleus and electrons are attracted to each other, resulting in a force called centripetal force, which can be mathematically defined as ke square over r square or mv square over r. Since an orbit requires energy, we can calculate the total energy from the sum of potential energy and kinetic energy. Kinetic energy is equal to ke square over 2r, while potential energy is equal to minus ke square over r. So the total energy is minus ke square over 2r. The negative sign shows that removing electron from its orbit requires energy. The weaknesses of this atomic model are: first, its stability is unguaranteed since the electrons continuously emit energy, causing the total energy and radius to eventually decrease. Second, the period of orbit will decrease as the radius is decreasing. As a result, the spectrum of a hydrogen atom is continuous spectrum. Based on Rutherford's model of atom, the energy of an electron in a hydrogen atom's orbit is Okay, so here's the solution. This energy is the sum of kinetic energy and potential energy. So, the answer is C.
Bohr atomic model was founded by Niels Bohr on 1913. According to him, the electron has certain orbit called stationary orbit. The angular momentum of the orbit can be counted using this equation. mvr equals to nh over 2 pi. H is the Planck's constant. M is the mass of electron. V is the velocity of electron. And r is the radius of orbit. On every orbit, electron has certain energy level. Electron can move to the other orbit. If electron move from the inner to outer orbit, it will absorb energy. If the electron move from outer to inner orbit, it will release energy. The radius of orbit can be counted as n to the power of 2 times r1. And the magnitude of electron energy can be counted as E1 over n to the power of 2. E1 is negative 13.6. Hydrogen atom spectrum. The emission of photon energy can be counted as 1 over lambda equal to R times 1 over Na to the power of 2 minus 1 over Nb to the power of 2. R is 1.097 times to the power of 7. There are some weaknesses to this atomic model. First, electrons' orbit surrounding the nucleus turns out to be very complicated. It can only explain hydrogen atom model. It cannot explain the influence of magnetic fields on the atomic spectrum, or known as the Zeeman effect. It cannot explain well events in chemical bond. So what is Zeeman effect? It is founded on 1896. It is defined as the division of spectral lines into two or more different components of frequency when the light source or atom is in a magnetic field. Here is the sample equation for Bohr atomic model. The electron energy at the ground state in the hydrogen atom is negative 1.6. The electron energy in orbit with quantum number n equals to 4 is it can be counted as negative 1.6 over 4 to the power of 2. The answer is negative 0.85.